Welcome to Simply Sustainability. Today we explore how research can lead to technologies that are better, greener, and more cost-effective, and how industry and entrepreneurship can help translate science into real-world impact without losing sight of planetary and environmental limits as they pursue innovation and profit. For today's episode of Simply Sustainability, I'm thrilled to welcome Dr. Desirée Plata, an MIT professor, entrepreneur, and leading innovator in material science. Dr. Plata is a School of Engineering Distinguished Energy and Climate Professor at MIT, Director of MIT Climate and Sustainability Consortium, and Director of MIT's Methane Network. Her research focuses on developing technologies that benefit society while reducing their environmental impact, especially in industrial areas. She's also a strong advocate for academic researchers partnering with industry experts to solve important environmental challenges. She's the co-founder of two climate and energy startups, Nth Cycle and Mox Air, and previously served as a faculty member at Duke and Yale universities. So let's dive right in. Hi, Dr. Plata. Thank you so much for joining us on another episode of Simply Sustainability. We're very thrilled to get to interview you today.
Thank you. It's my pleasure to be here.
So let's get started. You've spoken a lot about noticing patterns of illnesses in your family's hometown. How did that experience help you move from chemistry into engineering solutions for environmental intervention?
Thanks for the thoughtful question. You must have watched a lot of videos in advance preparing. So just to recap, for your listeners, when I was a young kid, I noticed a lot of illness in my grandmother's neighborhood, and felt like every other house somebody was struggling with some neurological disorder or a cancer. And I thought, well, there must be something everyone shares in common that could be a disease source. And so I had that hypothesis, I think when I was 8 or so, and then, went to college and ultimately found out that the home was located about a mile away from what the U.S. Environmental Protection Agency calls a Superfund site, or a site that's so contaminated that it has access to special resources to try and remediate and clean up that site. And I always had, a deep interest in environmental problems. But also solutions. And when I was in graduate school studying, taking my chemistry degree and applying it to Earth system science, it occurred to me that the work that I was doing wasn't going to keep, the next person from being sick, the next mom from being sick. And my aunt, who grew up on that same property, had been diagnosed with cancer, had 3 young children at the time. And I wanted to do something that was as proactive as possible to kind of provide access to fresh air, clean drinking water, and healthy soils for the world, really, because I think it's a fundamental right to me it's implicitly tied to our access to freedom and ability to thrive. And so I asked my PhD advisors at the time, do you mind if I switch my project and start working on something new? And I was really fortunate that they were supportive of that agenda. And I started just knocking on doors in other labs around campus, in electrical engineering and material science and mechanical engineering and aeronautics and astronautics. And the question that I was posing to those researchers was, what are you doing and how can I help do it better, with an idea of what the Earth system is going to, how the Earth system is going to respond to your technologies and what that means for the world. And the rest is history. I've kind of been on that path ever since.
Wow, so cool. I really like your approach about how you're preventing something from happening rather than fixing it after it happens. I thought that was really interesting and unique.
Yeah, thank you. As engineers, I'm really trained as a scientist. My undergraduate degree is in chemistry, and my advanced degree is in chemical oceanography, of all things. And I've applied that to materials science and industrially important processes. And what I think is really interesting is that when we teach engineering, we teach students to optimize for performance and cost. So whatever the functional performance is and cost. And what I've really tried to do and get as many people as I can to join me is think about incorporating environmental optimization metrics into that process. So what is the environmental performance of this process or material? And if we're doing our job right, that usually should cost you less through the lifetime, right? Less energy, less emissions, something that's more implicitly safe and benign, shouldn't lead to downstream health problems for your community, whether they're occupational health workers or the people who are using and consuming your products, right? No engineer wakes up in the morning and says, I want to see my technology last for about 20 years and then identify a major problem that poisoned myself or my neighbors, right? Nobody wants that. Our engineers, people in your generation, really want to think differently about the world that they're building, and I want to give them the tools to be able to do that.
Yeah, and this brings me to my next question. Like as you mentioned, you've talked a lot about using fundamental chemistry to design technologies that perform better and are both environmentally compatible and cost effective. So how does this commitment guide the way you design and choose your research?
Yeah. Well, I when I'm choosing a problem, I like to say that I work on orphaned problems. So, what's your favorite chemical contaminant, or maybe the most famous one that you can think of off the top of your head? I'm gonna wager a guess that a lot of your listeners would say PFAS. Like, I know what PFAS is, or I know what brominated flame retardants are, and those are really popular areas of study in my field, and that's great, right? We need a lot of people working on those problems to understand their environmental fate. But I like to work on kind of what I call orphaned problems, things that really need help and really need help fast, and that might also provide an example of how to do sustainable design better, an example of how to solve an environmental problem so that other people can follow those same principles and practices in their own work. Because I'm just one person. I have an amazing student team, but we don't have enough lifetimes, right? Like, I wasn't given enough life when it all started, and so I really want to recruit as many people as possible to this type of thinking and make it part and parcel of how we invent, so that we end up not getting into these messes that we've gotten into historically. Yeah.
Yeah, I think making research or anything replicable is really important, and yeah.
Oh yeah, I mean, reproducibility is a whole nother question that we really emphasize strongly. One of the roots, of my training are in analytical chemistry, actually, in analytical chemistry and complex systems like the environment. And so getting the same answer more than once is like critically important. And what you learn is that there are certain disciplines of science and engineering that actually don't maintain that same burden, because what they're discovering for the very first time might be super cool, even if it's only observed once. And so we're really trying to transition that to having better fundamental science, better high throughput data that is also reproducible. And those two requirements are provide a pretty high burden, I would say, but it's a necessary one, right? We still need really good physical science to be able to know what will happen in the future, be able to know what could happen from prediction. And so one of the things that I emphasize in my work is the timeline of innovation. And a lot of people see incorporation of environmental criteria as slowing things down. And that's traditionally true, right? I might give one graduate student one chemical, and then in 6 years, we might know a little bit about how that chemical behaves in the environment. Now, if you're a company, can you wait 6 years for someone to tell you what's going to go wrong? No way, right? Like, we have to be able to say, hey, company, like, do you have the chemical structure, or maybe the formula, or maybe you know a little bit about its chemical behavior? And now, if I know that, and I can tell you how long it's going to last in the environment, where it's going to partition into the body, the air, the soil, or the water, and then is it toxic or not, I can do a whole lot to help you build a system that is going to be implicitly compatible with the earth and the way that humans and ecological systems have evolved. And thank goodness I have the benefit of all that previous discovery to be able to do that. But that's the real dream, right? You give me a structure and I know enough that I can predict what's going to happen with it out in the world.
Mm-hmm. And in addition to all the research that you're doing, you're also the founder of 2 startups. So does the same philosophy guide your startup work as well? And can you tell us more about your startups and the impact that you're aiming to have through them? And also, do you see entrepreneurship as a powerful way to translate science into real-world change?
Yeah, I mean, entrepreneurship is so important in having your technologies translate into real world impact. And I'll say, For me, I'm not a patient person, and I really would love to see the impact of my work in my lifetime. And that's not to say anything bad about fundamental discovery, where you don't actually know what the impact is going to be. We need fundamental discovery. We never know where the next exciting innovation is going to come from. But for me, I don't want to wait 100 years or 50 years to see real change in our world. And so for me, sometimes starting a company is the right thing to do if you don't see an existing company that would be able to translate your innovation out into the world. And my mom still picks on me because she's like, well, I can't buy anything that you made at Walmart or Target or something. And I'm like, Mom, those aren't the kinds of things I invent. But but it still matters to people. So I think that that's where entrepreneurship is key. And we need so many climate and energy startups to try and grow and try and succeed, and a lot of them are going to fail. A lot of people quote this 10-to-1 ratio. You try 10 different things, maybe one of them works, and we need that because we need a lot of technological innovation to transition our global economic systems to ones that are environmentally restorative. So I'll tell you, really my eagerness around entrepreneurship has to do with timeline and wanting to see near-term impacts. The companies that I've started are two, and one of them is called Nth Cycle. So why recycle when you can Nth Cycle? And this company is really helped scale an electroprecipitation process that uses electrochemistry to try and sequentially recover metals in any kind of process flow stream. We focused so far on batteries, but you could imagine using the technology in mining or in recovered hard drives or from windmills or anywhere where there are critical metals present. And you might have heard a lot about rare earth elements or copper and cobalt and nickel and molybdenum and manganese. These are all metals that are really important to all of the functions that we perform, our national security. You're holding them in your in your pocket. Most people are. Some people are wearing them on their watch, and they're really necessary to modern life. And Nth Cycle looked at this problem and said, well, we want to be able to clean metals from waste streams. What if we could actually give those metals back to the user and allow them to make new products and processes? So the technology is working really well. Nth Cycle opened its first domestic nickel and cobalt production facility this year in Ohio. And I am super proud of that team. Everyone, I think, who's been through hard tech scaling knows how difficult it is. So just getting the technology to work is incredibly challenging. But one of the things that I particularly am proud of with their efforts is the workforce training that they provided to the locals. So one of the location was chosen on purpose. It's a part of the United States that used to have really robust auto parts manufacturing and still does in many ways. But there was a ready workforce who was really eager to engage with the STEM content and finds it very rewarding. And so we've been able to take people who lack access to 4-year educational degrees or even 2-year college degrees and train them to do really advanced analytical chemistry on the QA/QC side. And to operate the electrochemical systems and automate as much as possible. And it's just amazing to walk onto that floor and talk to those people who are doing the actual work to transition the economy to a restorative one and have them say, hey, I've got 3 new ideas about how we can make this process better. And so just seeing that joy in science that I have kind of spread to the rest of the world, I think is really lovely.
Congratulations on your first site, and I think all of the work that you're doing is very cool, like how you translated the problem that you saw in your hometown to this company now, or these 2 companies.
Yeah,
it's very cool.
Yeah, thank you so much. Yeah. And so Moxair is our other company, and this is a company that's really just getting off the ground. And we make systems that help reduce the methane levels in the atmosphere. Methane's like an orphan greenhouse gas that not a lot of people know about, but is about 85 times as warming over a 20-year time frame as CO2. And Moxair is trying to change the human interaction with that atmospheric reservoir, but basically undercutting methane's lifetime on its way to the atmosphere.
Yeah, that brings me to my next question. You've pointed out that even though CO2 often gets the blame, converting CO2 into methane can actually reduce that warming. So can you walk us through this logic and why it makes sense, even though it may sound backwards at first?
Yeah, so converting methane into CO2 is a good thing, which is super confusing for a lot of people. And I will say, if you had that thought, like, hey, this lady who calls herself an environmental scientist is making a pollutant, so did all the editors where we submitted this paper initially. And what I had to try and back up and explain the logic here is it's really simple at the end of the day. So methane, as pound for pound in the atmosphere, does more damage than than a pound of CO2, excuse me. So pound for pound, methane's about 85 times more warming than CO2 on a 20-year time horizon. And over 100 years, that methane will convert into CO2. So its natural fate over about a 10-year time frame is to become CO2. So the pound for pound warming potential methane to CO2 is about 25 times as bad. So what that tells us is that if we can accelerate the natural process, the methane turning into CO2, we would actually undercut its ability to warm the atmosphere. And so that's kind of thing number one, is that if we can accelerate that natural process, methane doesn't get a chance to warm the atmosphere like it typically would. And so that's thing number one. Thing number two is that there's a huge disparity between the amount of methane that's in the atmosphere and the amount of CO2 in the atmosphere. Do you know how much CO2 is in the room where you're sitting right now, or outside maybe?
No, but I know that there are those devices that can tell you exactly how much is being released into the air at whatever time.
Yeah, for sure. And so there's this really great record that was recorded at Mauna Loa that tracks the CO2 levels in the atmosphere. And the CO2 in the average atmosphere today is around 420 parts per million. So that means for every million CO2 molecules for every million air molecules in front of you, 420 of them are CO2, and only 2 of them are methane.
Oh.
So you could convert half of the atmosphere's methane into CO2, and it goes from 420 to 421. Atmosphere doesn't feel that extra CO2, but it does get a major warming benefit. And we think that if we could cut the atmospheric methane by about half, you would save maybe 16% of global warming by 2100. Now that translates to about a half a degree temperature savings, and that's a huge big deal for the atmospheric warming rate.
Wow, that is really innovative, and I don't know how you came up with that or how you researched that, but that's really cool. And I really hope that your startup works in pursuing this goal.
Thank you. I'm happy to tell you. I mean, it really all came from this place of worrying about industrial chemicals in the environment and being out in natural gas distribution systems. The fracking boom that grew in the United States from 2008 really until very recently. We were out looking in groundwater for industrial chemicals, and it turns out that it's actually pretty rare to have a contamination event from hydraulic fracturing chemicals themselves. But boy, that methane is everywhere. And so methane really is one of the larger environmental impacts from this hydraulic fracturing process. And what occurred to me is that we would need a way to destroy that methane at very low concentrations. So a question I get a lot of time is like, okay, so you convert methane to CO2. Isn't that what a match does? Or a flare or your natural gas burner? And that's absolutely true. This is just a combustion process. But when methane is so dilute that there's not enough of it there to light, you actually need a catalyst there to turn it into CO2. And so that's what we've done. We started to ask ourselves, what in nature actually acts on methane? And from my oceanography training, I knew that there were microorganisms that lived in suboxic zones, or places where there's a little bit of oxygen, that could use methane for their biomass or destroy it by converting it into other products. And so we try to mimic that chemistry in a non-living system so that we could get the chemical benefits at relatively low cost.
Thanks for that background info. That makes a lot of sense now. In addition to all this research and the startups, you also direct the MIT's Climate and Sustainability Consortium, which brings together major global companies dedicated to climate solutions. So can you talk about the work of the consortium, and also what role do you think industry can play in centering environmental and planetary limits as it pursues innovation and profit?
Yeah. What a great question. The MIT Climate and Sustainability Consortium is a collection of somewhere between 14 and 17 at any given day large member corporations, and so these are really large global corporations. You can look up the list online. I didn't ask them if I could talk about them in this context, but go look at the list. It's pretty impressive, and you have their products in your home and in and around you right now. And I'm just so thrilled. First of all, when they asked me to do this, because to me it's representative of a lot of hope, right? If these big global firms are excited about incorporating sustainability objectives into their mission, that's really what the world needs, right? Startups have a really slow growth process, and these folks are already out making decisions that matter. They matter to the earth, they matter to the economy, they matter to what the environment around us. And so if you can help talk through how we would build a sustainable ecosystem, build a sustainable economic growth model, build a sustainable society that elevates populations all at the same time, that's really, really powerful. And so we work on lots of different problems in the Climate and Sustainability Consortium, but all of them are things that we say will move the needle on climate, and they all have to have some common connection between the different member companies. And in environment, it turns out that's really easy to do, right? A lot of what got us into the sustainability mess that our world is in right now is by externalizing the impacts. And so the best example I can think of is your trash. So everyone has trash, right? You take your trash, you put it on the curb. It's somebody else's problem all of a sudden. And maybe you pay for your trash haul away, but maybe your taxes pay for the trash haul away. Or maybe you live in a part of the world where there is no haul away, actually. And so that problem becomes everybody's problem all of a sudden. And so that's an externality often, like something that is accounted for off of your own books. And so that becomes an issue. And so here we're saying, let's all come together and think about these things that have been classically externalities and think about how we can actually make some change. And the Climate and Sustainability Consortium has really developed some amazing products around this. So and I can give you a few examples if that's helpful. But we try to tackle really big problems that everyone's interested in.
Wow, I never thought of it from that point of view, like the externality thing that you mentioned with the trash. That's a really unique point of view. Moving on to my next question. So climate change cuts across every field, and this can be both a strength and a risk, because sometimes it can feel that no single discipline truly owns climate change. So what are the strengths in this interdisciplinarity of climate change, and where does it pose real challenges?
Yeah, it's such an insightful question. That this is a lasting frustration of mine, actually, because I would say not everybody's going to just roll up and do something important for climate, right? Like, you do have to have some technical knowledge on the problem. And but that said, once you have that technical knowledge, you can literally have any disciplinary skill set in your back pocket and do something meaningful for the climate and sustainability problem that we're all facing, or that maybe I should say the climate and sustainability opportunity that we're all facing. So if you like mechanical engineering, like come help us build new systems that are implicitly less energy consuming in the way that they do whatever the function is. If you like chemical engineering, let's design a process that's going to be biocompatible with the Earth system and maybe have a lower energy and chemical emissions footprint. If you like selling things, like we need business minds. If you like political science, economists, I'm begging you, like come help us think of new economic models. So no matter who you are and no matter what you love, you can do something important and meaningful for the climate change problem that we're facing, or the opportunity, as I like to talk about it. Because we really need to change our entire economic system, right? The way that we make money, the way that we live has to start thinking about how we internalize these externalities, or implicitly get rid of the polluting aspects of those technologies. And we can do that. It's I like to say it's improbable, but it's not impossible, right? The thing is, as you identified in your question, it's a really complex systems level problem. And so it really helps to have people who are eager to tackle problems where, you pull on one thread and it affects another system over here. And one of the things that's really challenging is getting that whole system to move in a coordinated fashion so the whole thing doesn't fall apart. And I will say that's a major vulnerability. People working in the space 20 years ago who have tried to stand up technologies, and where they failed, it's usually because some other piece of the system isn't ready yet. And we need those technologies to be there when the system's ready to transition. And so I'm really hopeful that we'll be able to do that coordinated economic transition soon.
Yeah, I totally agree. And I think collective action is a really big way to move forward in solving climate change, which is, as you mentioned, so interdisciplinary. And you just mentioned hope. And one goal of this podcast is to highlight climate progress. So in an age of climate anxiety, do you see reasons for hope? And what are some things that make you optimistic about combating the climate crisis?
Yeah, I mean, for sure. I'm super hopeful about the future, and I have a long list of reasons, tangible reasons why we should all be hopeful. The first thing that I want to encourage people to do is to look at the Earth's history, right? And recognize that the landscape of the Earth has looked different historically. It's going to look different in the future, and that's okay. We're going to be okay, right? It's going to be a gradual transition. There are going to be communities that are more impacted than other communities. And if you're in a community that's not as impacted, ask yourself how you can help other communities that are going to be facing more severe consequences. The trouble with that is that we don't really know where and when these big climate catastrophes are going to hit, like extreme weather events, drought, and flood. We're getting better at predicting those things, but they're hugely complex. And so we need, again, to kind of distribute our ability to respond and to build in adaptation and resilience into everything we do. Again, the Earth has been different historically. It is going to be different in the future, and we need to get ready for that. The second thing that gives me hope is that I see major global corporations taking a genuine interest in this. And they do that irrespective of geopolitics. I shouldn't say irrespective of geopolitics, but no matter who's in the leadership of some country, they're not changing their value structure, right? The fundamental business model might need to be tweaked, but the things that they value and care about are steadfast. They cannot oscillate on 4-year time frames, right? Geopolitics influences how they operate because many of the world's global corporations are just that, right? Global. And so they have to care about politics. They have to care about rules, but they don't have to change what they believe in and what their commitments are. And so many large global firms are truly committed to meeting the net zero goals that they set previously. And they're truly interested in seeing a world that they're proud to have helped build. And so that's a really good transition into the third thing that really gives me hope, which is young people and your generation specifically. I'm really hopeful and excited that people have taken an interest in climate change and sustainability writ large. And when I say that, I mean there are things that aren't quite captured by climate change, right? Like chemical contamination in consumer products or in groundwater or air. That's a big, huge deal. We need to start dealing with that. Plastics is a really good example of things that people can see and take photographs of, but might not actually have a climate connection that's easy to pull on. I always joke plastics is the pollution, my favorite pollutant, because it's the most Instagrammable, but it's brought a lot of attention to the earth problem where we're all swimming in a sea of industrial chemicals. You just can't see them. And so these types of things, like impacts on health, impacts on climate that are observable, your generation cares about, right? And they recognize that there's been a few narratives that they've been sold that are not quite right? The climate's changing, and if only we could change behavior, things would change, right? That puts a lot of pressure on the consumer that I don't think is fair, right? There are decisions being made outside of you at higher levels that kind of trickle down to the choices that you have access to. So that's, I guess one thing that I think has been basically a bill of goods that's been sold to people. Another is that, political will. If we just had political will, everything would be different. And it's like, what the hell is political will? And like, yeah, are they uncoordinated? Sure, yeah, and I think we can all recognize that. But I don't think your generation is going to put up with it any longer. Right. And hopefully you will be inspired to act through whatever it is where your skill set is. Right. If you have interest in politics, if you have interest in communications, if you have interest in STEM, there is plenty that needs to be done, but it does have to be done with some amount of coordination. And so that's item 3 that gives me hope.
Thank you for giving those insights, and those are definitely hopeful. And one of them that you mentioned was like the younger generation taking action. So what advice would you give to Gen Z or younger audiences who are interested in contributing to the climate crisis or climate solutions? Where do you think is a good starting point for them?
Yeah, well, I would say, so about this open learning course that MIT is trying to put together right now. It's called Universal Climate and Energy. It's not launched yet, but we're hoping within the next year you'll be able to access that content. And it's really oriented around solutions. So what are the solutions that you, an individual, could actually start working on and take up the mantle for in your own life? So if you're super eager to get started and you can't wait for that open learning Universal Climate and Energy course to launch, I would really encourage people to grab a book on the climate and energy problem. And the one I recommend is Bill Gates's recent book. I think it's called How to Solve a Climate Crisis, but I can get that accurate title for you. We'll link it. And it really breaks things down to how do we make things? How do we move around? Where do we get our food? Those types of questions. And if you think about those big systems that are the real problem, the real drivers of climate forcing, you can start to unpack where you might be able to apply your talents. And maybe that's the last thing that I would really want to leave people with, is that you don't have to be an engineer, you don't have to be a policymaker. You can really be whatever it is you like doing. Take something where you find joy and bring that to your everyday and apply it to a climate or sustainability problem, so that you can actually start to build that future that you want to exist.
Thank you for that advice. And this brings us to the end of the interview. So thank you so much once again for joining us. It was a pleasure to have you here today.
Yeah, it's a pleasure talking to you. Thanks for everything you're doing to mobilize the next generation.
Thank you.